Hi there, this is a question from exam 2, 2017 from the core section. So we've been given a time series plot there with area of hectares and the year, and we're looking at the eggs laid by female moths, by the female moths, and that hatch and become caterpillars. So from 1990 through to 1998. We have been given a table here with the year values, and we've been given also the values of the area in hectares. So the first part of the question, the association between area and the forest eaten by caterpillars and year is nonlinear. A log 10 transformation can be applied to the variable area to linearize the data. The equation of the least squared regression line can be used to predict the log area from the year is determined, and the slope of the line is approximately 0.885385. Round these values to three significant figures. So something in your bound reference is very necessary, and you should have should be something like this, which shows you all the different examples of significant figures. So in this case, we have a 0 point number. So if, for example, like this, so 0.000, we count significant figures after the last zero. So in this case, we've got 3, 5, and that last zero classifies as a significant figure. So having a sheet like this you can quickly refer to with different examples will be very, very helpful. So in this case, when we go to this question, round in 0.00855385 to three significant figures, our answer would be 0.00, which don't count as significant figures, then 854. So that is the answer for that one. Looking at our assessor's comments, only 44% of the cohort managed to do that. A lot of them included the zeros beforehand. Moving on to the next question. So perform the log 10 transformation to the variable area and determine the equation of the least squared regression line. Write the values of the intercept and the slope shown below. So this one here, there's two ways you can do this. You can get a picture like this, which has the circle transformations, and identify that it is this bottom curve, looking at the time series plot, and see that it's a log y transformation. Or you can actually just read the question, and here it says log 10 area, so that we're logging the y variable. So what you need to do is get your CAS calculator out and place all the variables for your x variable and your y variable into here. Then what we are doing, because we're doing the log y transformation, because area is the y axis, you can put down the bottom here log list 2, and you place the variable name in where your y is. So in my case, I've got list 2. If you've got leftover words or whatever, you need to use whatever it says up here into your list. We find out our log values, and then we can go calc regression linear reg. So that's calc regression linear reg, and we need to make sure we are choosing the right correct transformation column. So our new transformation is in list 3 for our y. Go OK, and it gives us our values here. So that e to the negative 3 means times by 10 to the negative 3, so we're moving back. And this value here in my case is my b value, my y-intercept, which is minus 14.396. So looking at our calculator, it's asking us for it in three significant figures. So if we go back to here, I can see that three significant figures would be minus 1, 4, and 0.3. The 9 is going to turn it to a 4, so it's minus 14.4. And in this case, if we go to the calculator, we can see that it's the value that was earlier on in the question, and we can put it to three significant figures, so 0.00854. So let's have a look at the solutions for that one. There's our correct answer. Only 37% of the cohort managed to get that one correct. Some students did not recognize that the rounded slope value came from part B. Moving on to our last part of the question. So the least squared regression line predicts the log 10 area of the forest eaten by caterpillars by the year 2020 will be approximately 2.85. So using this value of 2.85, calculate the expected area. around your answer to the nearest hectare. So this value of 2.85 is the value that we got, say, on our calculator after we logged our original value. Now, looking at some notes, you might have some examples of log transformations. So what this is meaning, this y value here is 2.85. We have logged an original value to get to our 2.85. So we can rearrange this to make the 2.85 to the top of the 10, and it gives us our final answer. Have a quick look at that and pause if you need to have a look at where the values are going. But back to the question, we can solve this by going 10 to the power of 2.85, and this would give us a value of 707.94578. And the question's asking round your answer to the nearest hectare, which would be approximately 708 hectares. So have a look at the solutions for this one. Only 29% of the cohort managed to get that one correct. So this was question was not answered well. Some common answers were 709. So there we go, a question from the exam one that was not done overly well. So this first part was only correctly completed by 44% of the students in the cohort. This question was only completed correctly by 37%, and this question was only completed by 29% of the students correctly. So some easy marks there that you can get on some other students. Hopefully that helps.